Hi. Today we're going to talk about section 5.6, which is called the remainder theorem and the factor theorem. Let's first off start talking about this thing called the remainder theorem. Okay, what the remainder theorem is going to allow us to do, it's going to allow us to evaluate functions. Okay, and we've evaluated functions before. We've seen functions like this, and you've been asked to find the value of the function when x equals 3. Okay, and one way to find that value of the function is the way that we did it before. Okay, we did it by what was called a direct substitution. Okay, if you remember what a direct substitution is and how this worked, is that we took the number in the parenthesis and we plugged it in everywhere we saw an x. Okay, we directly substituted it in there. Okay, and if I plug this in there, I kind of did something like this. Negative 3 something squared plus 5 times something plus 4. And again, the number, the 3, I plugged in there everywhere I saw x, and then I evaluated it. Okay? And this is something you can simply do all right on your calculator. Okay? But if I kind of worked it out here, 3 squared is 9. 9 times negative 3 is negative 27, plus 15 plus 4. Okay? And if I combine those together, I would get negative 8. Okay, I did that kind of fast, but that's what's called a direct substitution. And that's one way to evaluate a function. Okay? Well, another way to maybe possibly evaluate a function is we're going to talk about synthetic division. And this is something we did a while back. Okay? But up here they have the same function that I had a minute ago. And we're going to divide it by x minus 3. Now, if you remember in the previous page, they wanted us to evaluate the function f of 3. Okay, and there's kind of a relationship between this number and that, but we'll come back to that in just a minute. Okay, I'm going to take this function up here, and let's divide it by x minus 3 using synthetic division. And if you remember, synthetic division works kind of like this. Okay, the top row of numbers here comes from the coefficients of the function. So this was negative 3, 5, and 4. Okay, the number that went out front out here was the opposite of the number that we were divided by. So x minus 3, looks like negative 3. We're going to put a positive 3 up there. Okay, just store that in the back of your mind. You've got f of 3. Okay, let's see how this works. And if you remember, using synthetic division, this is how the process worked. I dropped down my first number. Okay, and the two key magic words here with synthetic division were multiply and add. Okay, so we multiplied these two numbers, which is negative 9, and it goes right here. And then I add 5 plus negative 9, okay, is negative 4. And then again, I multiply, take that number out front, multiply it here, and I get negative 12. And I add, and I get negative 8. Okay? And when we did synthetic division before, this was what was called our remainder. Okay, the last number here at the end. And, well, let's take a look at this for a second. Let's think about, what did we do a minute ago when we did direct substitution? When I just took that 3 and I plugged it into the parenthesis there, I ended up with negative 8. Look what we ended up here when I did synthetic division, when I divided by x minus 3. Got the same remainder. Okay? Well, right there, that's demonstrating this thing called the remainder theorem. Okay? And this just kind of shows it again. There's the function. Here's the direct substitution, like we did on the first page. They got negative 8. The value of the function is the same as the remainder. Okay, and that illustrates the remainder theorem. Okay, and what this basically allows us to do, okay, is that it allows us to use another method rather than direct substitution to evaluate a function. Okay, if I divide by x minus r, the value of the function is f of r. Again, it's kind of the opposite of whatever's up there. Like I said here, if I'm dividing by x minus 3, the value of the function is f of 3. If I'm dividing by x plus 5, I would be evaluating f of negative 5, is kind of what I'm getting at. Okay, and these things can kind of go back and forth. Okay, we're going to practice a couple here in a second. Okay, here we go. Okay, and your instructions on your homework today are going to say, evaluate the function using synthetic substitution, or synthetic substitution. Make sure you show your work. Make sure you show synthetic substitution. You can use your calculator as a check. You can do the direct substitution and plug them in, and you should get the same answer, but make sure you show your work using synthetic substitution. So here we go. Okay? So up the top row, I have a 3, a negative 2, a 5, a negative 6, and a positive 2. Okay, and while I'm thinking about it here, just a reminder, when we did synthetic substitution and division before, every exponent had to be accounted for. Fourth power, third power, second power, first power. And if it was missing one, we had to put in a 0. Okay, I think today most of the time they're all going to be there, which they are. But just do a quick little check. Okay, now I'm evaluating f of 2. So I'm going to put a 2 out here. Okay, and my answer, the value of that function is going to be my remainder way down here at the end. Okay, let's check it here. If I drop down my 3, and then again the two key words here are multiply and add. So I'm going to multiply 2 times 3 is 6, and then I add. Negative 2 plus 6 is 4. I multiply, 2 times 4 is 8, and I add 13. 2 times 13 is 26, and I add again. Negative 6 plus 26 is 20. 2 times 20 is 40. And 40 plus 2 is 42. Okay, the value of my function, this function when x is 2, is 42. Okay, and that's the type of work I expect to see in your guys' assignments and things. Okay, you can certainly use your calculator, like I said. You can take this 2, and you can plug it in there, 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 and there. You can do it all right on your calculator, just the way it is, as a little check. Okay, so kind of a nice, easy way to check. Okay, try another one here. Okay, let's use synthetic substitution to evaluate this function when x is 3. So again, my coefficients are 3, negative 6, 1, and negative 11. And I'm putting positive 3 out front. Okay? And again, I'm going to drop down my first number all the way down. That's my starting number. And then I multiply and add again. Multiply and add. So 3 times 3 is 9. I'm going to add. Negative 6 plus 9 is 3. 3 times 3 is 9 again. 1 plus 9 is 10. 3 times 10 is 30. And 30, negative 11 plus 30, I think is 19. This would be my answer right here. Okay, so that's what that remainder theorem is telling us, that when we do synthetic substitution, okay, the value of the function is the remainder. Okay, so it's not too bad, not super fancy math. Okay. Okay, why don't you take a second and try this one by yourself. Okay, push pause on the video, set it up. When you're done, unpause, and let's check your answer. Ready, set, go. Okay, all right, welcome back. Let's set it up here. Okay, oh, now be careful. This is kind of a tricky one. I'm looking at the exponents. The 5th power, and then it goes to the 3rd power. There isn't a 4th power. We need to put in a 0. Okay, and then a 2, a 1, and it's also missing an x term, just an x to the 1st power. I need another 0, and then a negative 1. Okay, so here's one where we had to add the zeros. Okay, be really careful and cautious of that. And then I want to evaluate f of negative 1. I'm going to put a negative 1 out front, and then I'm going to multiply and add. So I'm going to drop down my 4, and I multiply. That's negative 4. 0 plus negative 4 is negative 4. Add, I get positive 4. 6. Negative 6. Add here, I get negative 5. Here I get positive 5. Add, I get 5. Negative 5. Add it together, and I get negative 6. Okay? And once again, I can certainly check that by using my calculator. Okay? If I type this in, I get 4 times negative 1 raised to the 5th plus 2 times negative 1 raised to the 3rd plus negative 1 squared minus 1. And if I did that on my calculator, or you did that on your calculator, it would tell you negative 6. Okay? So again, use your calculator as a check, but make sure on your homework assignment you show your work by using synthetic substitution. Okay? So once again, that demonstrates the remainder theorem. Okay, the next thing we're going to talk about is the factor theorem. Okay? But here's a question for you. What does it mean if something's a factor of another number? Okay, if something is a factor, like for example, I said 6 is a factor of 12. 5 is a factor of 15. 3 is a factor of 9. Okay, maybe you're starting to get it. What a factor is something that divides into another number evenly. And if something divides into another number evenly, what do you think it has for a remainder? Yeah, its remainder is 0. Okay, so if something is a factor of another number, its remainder is 0. It divides in evenly. It doesn't have a remainder. Okay? Well, what this factor theorem is saying, okay, that a binomial is a factor of a polynomial, and this is a geometry term here, IFF, if and only if it has a remainder of 0. Okay, and we'll see here that this factor theorem can also help us find all the other factors of a polynomial. So what it's saying is, okay, if I had a binomial, maybe it was x plus 3, again it only has 2 terms, okay, and I divide it into some other polynomial. It may have 2 terms, 3 terms, 4 terms, 5 terms, doesn't matter how big this one is. But if I did it using long division, again, and I worked it out, it would have a remainder of 0. Okay? And we're not going to do long division, thank goodness, right? Okay? But what it's also saying is, if I use this synthetic substitution thing, okay? And again, if I had like x minus 2, for example, a binomial, I put a positive 2 out there. Okay, again, it's the opposite of that number. And again, no matter how many terms this had, but when I get down to here, its remainder would be 0. And what that tells us is that it divides in evenly and is a factor. Okay, so maybe kind of guess this. What we're going to do here is we're going to do synthetic division again. And we're first off going to check to see if something is a factor. We're going to check to see if its remainder is 0. Okay, and then we're going to use this answer here to kind of help us find the other factors of the polynomial, as you'll see here shortly. Okay? All right, so here's an example of one. Okay, so I have a polynomial. It has 4 terms, and I want to know if this one, x minus 5, is a factor of it. So I want to know if it divides in evenly and has a remainder of 0. Well, let's check it by doing synthetic division. So we first of all have to check, yes or no, does it work? Is it a factor? Okay, well, if I look here, I have 3rd power, 2nd power, 1st power, all the exponents are there. So I'm going to write my coefficients, 1, -7, 7, and 15. Okay, and then what I put out here, it's the opposite of that, what's in that binomial. It looks like -5, but we're going to put a +5 up there because we want to check to see what makes that go to 0. Does it go to 0? All right, let's give it a whirl. I'm going to drop down my 1, and I'm going to multiply and add. 5 times 1 is 5. If I add here, I get -2. 5 times -2 is -10. Added, I get -3. And 5 times -3 is -15. Aha! And when I add these together here, I get a 0. Okay, so the first part of this is yes, it is a factor of this polynomial. Okay, and you have to prove it. Your work, once again, your work has to show it. It has to prove it. It has to show me that it equals 0 right there. Okay, now the second part of this question is asking us, find the remaining factors. Find the others. Well, where do they come from? Okay, well, the other factors, there's other things that divide into that polynomial. Those other factors come from this, right there. Okay, the leftover stuff of our synthetic division problems. Okay, now if you guys remember doing long division, if I did do a long division, okay, if I started with x to the 3rd, what did I multiply x by to get x to the 3rd? It's x to the 2nd. It was 1 less power. Okay, what we're going to do is we're going to translate this back into a little polynomial expression. And what these numbers are is they are the coefficients of the answer. So this is really saying 1x It started with the third, so it's 1x squared minus 2x minus 3. Okay? So do you see how we change that back into a polynomial? And those numbers are the coefficients. Okay? And we don't really need the 1 there, so I'm going to take that away for a second. Okay? But it wants to find the other factors. Now it wants to find what other numbers go into that expression. And the way we're going to find that is we're going to take this and then we're going to factor it. So we're going to do the old factoring that we did a long time ago. And remember, I look here first. The factors of x squared are x and x. Hang on a second. Okay. Then we're going to look at the last number, 3. And its only factors are 1 and 3. And can we put them in there such a way so that when I FOIL, when I do this and this, I get -2. And if you think carefully, or try one, I just plug in 1 and 3. It's my only choices. Okay, this gives me 3x. That gives me 1x. Can I get -2x? I need to get the middle number. I think it works if I did a -3 and a +2. I'm sorry, -3 and +1. And right here, these are my other 2 factors. Okay, so once again, we're going to tie in all this, a bunch of separate individual things that we've done in the past. We're going to tie it all together and use the different pieces to help us find certain things. So what I did there is I did long division, or synthetic substitution, synthetic division. I showed that it equals 0, and I said, yes, it was a factor. The way we find the other factors is we take the leftover stuff here, change it back into a polynomial expression, and then we factor it. Okay? And that's the second part of what we're going to be taking a look at today. Let's try another one here. Okay? Here's a polynomial expression. It wants to know, is x minus 2 a factor? Okay, well, let's see. A 1, -7, 4, and 12. 3, 2, 1. All the exponents are there. And if I want to see if x minus 2 is a factor, I'm going to put a +2 up there. And again, it's the opposite of what it looks like. And if it is, we're trying to see what number do we get right down here at the end. We hope it's a 0. Let's try it. Okay, if I drop down a 1, I get 2. -7 plus 2 is -5. I multiply again, I get -10. If I add these together, I get -6. 2 times -6 is -12. And lo and behold, if I add these two together, if I add those together, I get 0. Okay, so once again, this was a 10. Once again, yes, the x minus 2 is a factor. Okay, and then to find the other factors, I need to take this stuff right here and change it back into a polynomial. This changes back into x squared minus 5x minus 6. Okay, and then last but not least, the last part of this puzzle is we have to factor that. So I'm going to do my 2 parentheses. I can do x and x. It's my only choices. Now be careful with 6. This is a tricky one. We can do 1 and 6 or 3 and 2. And we need to get the magic number -5. Well, I can get -5 out of both of those. 1 minus 6 is -5, and so is -3 minus 2. Okay? What if I did -3 and -2? That gives me -2x. -3x is -5x. But I'm going to tell you that one's not right. And you think, what? Why is that not right? It sure looked like it worked. Well, watch what happens if I was to continue foiling here in the last ones. What kind of a 6 does that give us? -3 times -2 is +6. And it says it has to be -6. Okay, so it looked like it worked right off the bat, but unfortunately, it did not. Okay, so that tells me, that the 3 and the 2 didn't work, and that I have to use 1 and 6. And I think I have to do -6 and +1. If I foiled again, -6x plus 1x is -5x, and if I foiled the last ones here, a positive and a negative does give me -6. Okay. So the second part of my answer, the 2 other factors are this and this. Okay, and we're going to use this idea of using synthetic division, finding a factor, and converting these into other factors as well. We're going to continue to use that in lessons down the road here as well. Okay? All right, let's do one more together here. How about this guy? Okay? If I did 1, 2, negative 1, negative 2. And out in front now here I have an x plus 2. Think to yourself, what would you put out in front of that synthetic division symbol there? If it's an x plus 2, we're going to do a negative 2. Okay, let's see if it's a factor. Let's see if what its remainder is kind of what we're looking for. So if I drop down the 1, I get negative 2. I get 0. Negative 2 times 0 is 0. Add it together is negative 1. Negative 2 times negative 1 is positive 2. And lo and behold, look at that, it worked. So once again, yes. Okay, x plus 2 was a factor because it has a remainder of 0. And now let's change this stuff back. This turns into x squared. I start with the third power, so this is x squared plus 0x. Well, I'm not going to write 0. Minus 1. Okay? Now, is that factorable? Okay? We did take, this is a special one that we took a look at a while back. It was one of those special ones, and there's only 2 terms being separated by subtraction. And if you remember those are perfect squares. Okay, and the way that this worked is I did the square root of each one. The square root of x squared is x and x. The square root of 1 is 1. And the signs that go in there, 1 is plus and 1 is minus. And there are my other 2 factors right there, x plus 1 and x minus 1. Okay? All right, very good. Okay? All right, here's the last ones. I want you to take a second, okay, and do these 2. Push pause. Try them on your own. Okay, when you're done, push unpause and we'll see how you did. Okay, but use synthetic division to evaluate the first one, what x is, x is negative 5. And then the bottom one, do what we just did a minute ago. Check to see is x minus 4 a factor. If it is, find the other factors. Okay, push pause, give it a shot, and tune back in a minute. Ready, set, go. Okay, all right, welcome back. Let's give this a shot. If I was to try my synthetic division up here, I have a 2, negative 8, negative 2, and a 5. And again, I notice 3, 2, 1, all the exponents are there. And when I'm evaluating the function, I'm going to put a negative 5 up here. Oops, a negative 5 out in front. Okay, here it's the same number. I'm going to drop down my 2 and then I multiply and add. So I'm going to get negative 10. That's negative 18. Okay, negative 18 times 5, I believe, is 90. Just to double check here. So, yes. Okay, and I add. Negative 2 plus 90 is 88. Then I have to do 88 times 5. 88 times negative 5 is negative 440. And if I add those, I get negative 435. So wow, kind of a big number. Okay? But once again, just so we're all crystal clear in your homework assignments and things, I need to see the synthetic substitution. Okay, one really quick and easy way to check your answer again is to use your calculator, and that's where you can take the negative 5 and plug it in there in all those places on your calculator. And if you did it, I think you would get negative 435. Okay? All right, and last but not least, last one for the day here. Let's take a look at this one. Is x minus 4 a factor? Well, let's check and see here. Okay, if I do my 2, 7, negative 53, and negative 28, again, I don't need any zeros because all the exponents are accounted for. And if I want to see if x minus 4 is a factor, we're going to put a positive 4 up here. This time, when we do these, it's the opposite. Okay, let's do the same thing. I get 8. Plus 7 is 15. 15 times 4, if you did it on your calculator, is going to be 60. If you add these together, I get 7. And 4 times 7 is 28. And look at that. I got a 0. That's good news. We like that. Okay, so that means yes. Okay, x minus 4 is a factor. And make sure on your homework and things, you write the word yes if you get a 0. Okay, then lastly here, we're going to take this stuff and we're going to change it back into a polynomial expression. It's 2x squared plus 15x plus 7. Okay? And then we want to factor that. Okay? When I look at the first number, the only choices are 2x and 1x. When I look at then I go to the last number, the only choices are 1 and 7. And I need to put them in there so that I get a 15. Now remember, from factoring, whatever number goes back here is going to get multiplied by 2. If you think about it for a minute, I think I want the 7 to go back here and the 1 there. Because I get 14x plus 1x when I FOIL, which is 15x. And to get a positive 15, they're both positives. Okay? And there are my other two factors right there, 2x plus 1 and x plus 7. Okay? So again, there's basically two things we're doing on your homework assignment. We're doing, well, these two types of problems. We're determining if something's a factor, okay, checking to see if it equals 0, and then factoring to find the other factors. Okay? And the other thing is you're going to evaluate functions by using synthetic substitution. Okay? Thanks for tuning in.